Welcome to Study Loop.
Hello and welcome to Conceptual Physics, chapter number 9, problem number 96. So this problem tells us that Jupiter, the planet, is about 300 times more massive than Earth, but it presents an odd sort of problem in that the force due to gravity on Jupiter makes a person. You would think that that huge difference in mass would create a whole lot more issues with the force due to gravity, your weight. But the issue is that there's not. It's 300 times more massive than Earth, but however, the weight, the force due to gravity is only 3 times as much than on Earth, and it asks us to discuss this. So the really important thing in the gravity equation, the force due to gravity equation that I have written over here, is this value r squared here. That's what's going to really influence why it's so much different. So we can kind of ignore some of these other values. I'm going to go through this as if we're actually solving this problem. G is going to be the same for both Earth and for Jupiter. And the mass of the other object or other person, I'm going to call that M2. That's going to be the same, right? You're not going to change your mass. But the difference is Jupiter has an M1 is 300, whereas Earth is 1. So why is it so much different? And the reason that is because the radius of Jupiter itself is 10 times larger than the radius of Earth. So when you think, and so that what that really does is that you put that in that r there and you square it. So instead of even having 30, you have 300 divided by 100. That's really, you can just say that if you're calling these forces proportional, or these this force from the Earth and from Jupiter. So the real issue is that the radius here r is 10 times larger than Earth's, and then when you square that 10, you get 100. So that's why it's so much different, because Jupiter is so much larger than Earth, that gravitational pull has to cover a much larger distance, and that inverse square law coming up again really does play into how much that changes your final force.